All right, so good morning, everyone, and Happy New Year. And I think this is the same faces we see last year in my machine learning class. I think there's a couple of new students as well. So anyway, Happy New Year, and it's great to see you guys again, right, in this awesome course, NLP slash ChatGPT, whatever, right? Before anything else, to access my course, you can go to my website and then scroll down, right? And right here, you will see a course named Natural Language Processing. So you can get the slides, you can access to all the code used in this class. All the code I wrote is archived in all the GitHub, and we also have YouTube. This is something new in our class. So previously, I taught the coding session in the class, and it takes 6 to 7 hours because there's a lot of different people with different levels of skills. So I have to personally go to your desk, ask what is your problem, fix a lot, go back and forth. And I realized that teaching in the class may not be the best solution for coding because everyone has their own speed. Some did not set up the Huggingface, some did not have the Python installed, right? So this is a year that I newly implemented YouTube. So I pre-recorded all the coding session in YouTube, right? So later on, I'm going to show you the playlist is not yet done. I and my TA plan to record a total like 50 videos, 50. So it should be good enough for you to get all the coding skills you need for your success, right? Great. So yeah, hopefully you can firstly get all the resources, right? So let us go to what we're gonna do today. So today, the plan is very simple. We're gonna teach big picture of NLP. Basically, like it takes maybe 30 minutes to set up the grading system, what we expect, what you should expect from me, and the course difficulty, etc. And then we're gonna spend 1 more hour on the actual materials right away, right? So today, you can decide whether to enroll this course or not. All right, so welcome again to my course, and my name is Chaklam. For those who don't know me yet, I'm actually from Hong Kong, China, and I can speak Thai, of course, but I prefer. Yep, I'm actually from Hong Kong. Yep, and all the course materials can be found in the GitHub. We will look at each of this URL later on very soon. So all the coding code is on GitHub. All the slides is also on the Google Drive, right? And the Moodle will be where the assignments will be posted, right? And the YouTube is etc. here. And appointment. If you need any help, personal help, you can appointment via my calendar. Go to Google Calendar, subscribe to this calendar, and you will see all my schedules. And then you can just say, I want to talk with you. You don't need to chat with me. Are you available? No. If I'm free there, you just book. And then you can come to my office right away. You don't need to say, Chucky, are you free today? No, right? Just go to the calendar. Yep. And of course, the TA is also very busy. I'm very picky on choosing the TA because I believe that the TA must be very knowledgeable, like the most knowledgeable possible to help all you guys. So he knows everything from theory to practice. I think I chose probably the best guy already. So maybe, again, maybe you want to introduce yourself a little bit.
Yes. Okay. My name is Thoswat Tanpatan. You can call me Kan. Yeah, this is my email. It's T123012. You can book the schedule as well as a check-in. You can check in my schedule. And yeah, I take responsibility about the quiz, the assignments, and your project. and whatever so on that you want to help. Yeah, you can ask me anything if you want to help.
Thank you very much. All right. So that is our TA. So again, he will be responsible for all the assignments, and he will post all the solutions. And let's see, maybe if you guys really have difficulty with our assignments, then he will also put a YouTube video to actually teach you line by line how to do the assignments. Okay, so we tried our best to actually make you successful, but you also need to put your time on this course, right? And also projects, quiz, he will be all the one that actually handle all the logistics, right? So that he will be the one to contact with. I only teach. Yeah, my responsibility is to teach. If you want to find a textbook, actually there's no good textbook because NLP is a very fast updating area, right? Every day there's a new papers coming out, and there's no one can actually get a good glimpse like what is NLP right now, because the area is, I believe that NLP is probably one of the areas that is growing the fastest in the world currently, right? I'm not sure other areas, but I think NLP is one of the biggest areas. But if you ask me what is the book that I recommend you to read, if you feel like Chucky, you sucks at teaching, I rather read another book, then yes, this is the book I recommend. Another resources that I did not put it here, maybe I can put it later on, is Stanford. So Stanford has also a course called NLP. And of course you can take a look, but I can guarantee you that I and Gun has done a big job trying to survey what Stanford, MIT, CMU taught, and I'll try to get the best out of them, right? Because we want to teach you the best materials, right? And yep, best taken after computer programming. Who took computer programming already? Yeah, I guess everyone. Who took machine learning already? Yeah, I remember your faces. Yep. For those who did not take, can you take my course? Yes, but you need to work a little bit harder in the beginning, right, to catch up with everyone, right? So that's the logistic. So let us take a look at each of the photos, right? So the first photo is the Google Drive. Again, if you don't remember any link, at least remember my name, right? Chaklam. And then just .com, you go down, you go to the courses, you get slides, GitHub, YouTube, right? So everything should be here. So now for the slides, you can take a look, right? And it follows, so there are a lot of topics we're going to talk about, right? I'm not going to talk here. And there's also an archive folder, right? These are the materials I won't teach. Yep. Later on, I will show you some comments of the previous class, and so I cannot teach you everything I have in my brain, but I have to focus on something that I think I can teach you, such that you don't get stressed out, right? So I try to remove something, but for those who are very genius, you want to know everything like me, and you want to know also very deep, you can go to this archive folder, right? Otherwise, if you don't think that, no, Chucky, I'd rather focus on the basics, then that should be enough, right? There's also appendix. So yeah, you can take a look, right? But anyway, there's a lot of materials in this Google Drive. And the next one is the model, right? So everyone should access this model by, I think, next week, right? In which, by the way, for everyone, all the YouTube, all the lectures that I'm teaching right now will be posted here. There's a very high chance that I will convert all this Zoom record into YouTube, so that for those who graduated already, you can come back to watch my video. Yeah, because last year, someone talked to me that the Zoom video is gone somehow. Yep. And for the assignments, I will talk later, but you can see search engine, text you're gonna generate Harry Potter. You're gonna do machine translation. You're gonna do Huggingface, sentence bird, distillation. You're gonna do a chatbot for AIT. Yep. You may think this is difficult. I don't think so, right? Yeah, yes. So we have all the YouTube to support you, but we also have a very clear, I think all the PDF is posted, right? No, you did not post the PDF yet, right? It's in the GitHub, right? Yep. Yep. And so this class is very heavy on assignments. So every assignment is like a quiz. You can think like assignment is like a quiz. And you take home, you do it. You can use ChatGPT. I don't mind. I understand that you are in the world of ChatGPT. So if you think you can solve my assignment using ChatGPT, be so. Be your friend, right? But at one point you will realize that ChatGPT gives you wrong answers, right? Then you have to search a lot of materials, right? So I'm okay with ChatGPT if you think it can help your work. Quiz, there will be 3 quiz, right? And this quiz will be a take-home quiz, right? In which and it's a time bracketed. So but we haven't decided yet how do we do. So maybe one people start 1 hour earlier, the next group start 1 hour later, the next group start 1 more hour later, right? But all the quiz time is around 3 hours or 2 hours, right? So we want to make sure that you guys don't copy. At the same time, you can also exhibit all the creativity. You can use ChatGPT if you think you can solve our quiz, right? But we try not to make you do that. Yep. Of course, project, right? So Moodle has everything, right? So make sure you go in here. Yeah. GitHub. So again, the link is in my website. The GitHub is made in such a way that it's very clean, right? You come in here, the folder that you need to pay attention is code. All right. So I already split into very clear fundamental, deep learning, SpaCy, Huggingface, retrieval augmented generation, basically chatbot, ChatGPT, whatever you want to call, multimodal. So multimodal is like you have a picture, you want to ask a question. How do you do it? Reinforcement learning, human feedback. So if we want to create a chatbot, it get a response. How do we ask the reinforcement learning? You remember PPO? We learned PPO, right? Even though it's the last class. We're gonna just teach you very quickly using library. How do you train a model to learn from human feedback? Like this response sucks. You should not respond like this, right? Then it can through 1,000 responses and feedback, the chatbot can be better, right? So there will be a lot of materials you can go in. Fundamental, for example, Watervex from scratch, and is your favorite PyTorch, right? So if you took my machine learning course, everything will be fine, right? So all the code is written here, and if you don't understand, then you will need to watch my YouTube. So yeah, that is basically it. You notice that in my repository, there's no Docker, there's no ML flow. So so it's created in such a way that I don't expect you to know Docker. I don't expect you to know ML flow. But of course, you can integrate it in your projects, whatever, right? But I want to keep this repository legendary and very clean, right? And make sure you give me stars, right? So that's just for your information. Yep. Now go to the YouTube. The first thing I want to tell you is that you should not expect too much from me because I'm not a YouTuber, okay? I'm not a YouTuber. I don't know how to edit videos. I don't know how to make very flashy. I don't know, okay? But I try my best to record my video with good voice, etc. And you can watch, but he will tell you which video to watch to do what assignments, all right? So, yes, good morning, students. And today I will be, maybe you can glimpse a little bit. Teaching. I think the resolution will improve later on. And there are a couple of things we're going to do today. First is loading data. So we're going to be loading some very small data to make sure we don't spend too much time on this, but make sure that my code can actually work with any CSV file, which will be on your assignment anyway. And then on the second, we're going to prepare some train data and then do some model, and perform some training, and plot the embeddings to know that things are closer or not, and then do some cosine similarities. All right. Without further ado, I think we should import something first. So we're gonna do import. All right. So I think that's it. All right. Let me make my screen bigger. Okay. So that should give you a good idea about the video, right? And this is not all the videos I planned. Actually, I took this during Christmas until now, and I still need a lot of time to record even more, right? So it's only until Huggingface, right? So there's like 20 or 30 more, right? And TA will also record his space soon. Yep. So that is the idea, right? So again, YouTube will be the main source of knowledge that you know how to code. I won't teach you code in the class because I realize that, again, a lot of people are already here. If I teach in the class, it takes 6 to 7 hours because some people have problems, some people don't have problems, and I go back and forth, stop, pause, takes too much time, right? It's not a good format. And I found that YouTube, you can skip my bullshit and then just go to somewhere. Oh, this part is very difficult. You run and play again, right? So I think YouTube is the right format to learn coding. Yeah. So anyway, that is the YouTube, that is the GitHub, and that is the Moodle. And so there's a lot of materials prepared for you for your success, right? Now, I also give you some idea of past students, what they feel, right? I have to explain that this course is difficult, all right? It's by nature difficult because I know a lot, my TA knows a lot, but when I say I know a lot, I say I know a lot compared to you. But when I compare to the world, I know averagely. I only know average, enough to work in the industry. So if you think I know a lot, no. So that's why if I want to make you work in the industry and compete in the industry, I have to throw a lot of knowledge in a minimum in a 3 months, right? So you have to understand my point of view that I'm not trying to throw a lot of stuff, but if I only teach you this, and if you think you know already, it's no, right? So you have to understand that I try my best, right? So in the beginning, you will suffer a lot for those who like have problem in coding, right? Assignments will be difficult for you. Some assignments, we only need you to write like 3 to 4 lines of code if you know that, right? But they are not designed to be very difficult, right? But anyway, I highlight like foundation practices. He complained a little bit. He's trying to cover too much, right? But yes, I try to delete already. I already tried to remove some slides to the archive folder, right? But I still need to teach, right? A very difficult course. Assignments could be more simplified and easier to, we already did that, right? But we could not make it even more simplified, right? I hate quiz. Oh, later on, you will find out that we don't have exam in this class. We don't have midterm, we don't have final. We only have assignments and quiz. So assignments is like quiz. Quiz is like quiz. Quiz is like exam. Understood? So they are treated very seriously, and we want to make sure you put all the efforts in assignments and quiz. In machine learning, it's different. In machine learning, I treat you guys like a people who don't know how to code. So assignments is like, okay lah. In Thai, it's okay lah. Give you point lah, right? But now that you guys are more seasoned, then we should treat it more seriously, right? You can think like this: assignment is something that your boss tell you to do, and he can do in few hours, right? So if he can do in few hours, we give you 1 week. That should be plenty, right? So the logic is like that, right? So now let us look at the big picture first, right? How about we save this when we actually learn the lecture 1, right? Which will be in a couple minutes later, right? Because this slide take a lot of time. So course overview, the course objective is you're gonna learn word representations. How do we represent word so that computers know the meaning, right? Have you ever wondered, like, words, computers is represented by 0 and 1. So how do computers know that smiling is what, right? How can numbers translate to smiling, right? So that is the question that scientists need to break down. The next one is we're going to implement all the basic neural architectures from INN to transformers. So this should be able to cover you all the basic architectures that you need for implementing your own model. But later on, for those who are researchers, you may want to keep implementing your own architectures, right? But for industry people, you may want to use Huggingface, for example, right? Just load the model, tune a little bit, and make your stuff, right? So those are some of the things we're going to also cover in this class, which is an advanced topic. So yeah, here you will see quickly blue and red. So what is blue and red here? So blue, I think if this is a 6-week course, that will be the things I will teach you. That will be the things that you must know. You must know, like no way you cannot know. Like you must know, all right? Because like go by and blah, 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 until pre-train models, you must know, right? To work in this industry, right? How about the red one? The red one is good to know, all right? It makes you unique from other people, right? So if everyone knows this already, what makes you unique? You can be specialized in PEP. You can specialize in quantization. You can specialize in question answering, paraphrase, instruction tuning, right? You should specialize in some areas, right? But not all, right? But in this course, we're going to teach you everything that we know, but eventually you have to specialize in some areas, right? For example, Pirun, right, is already working in my lab and he is working on multimodal learning, right? So that is what he chose to be specialized in, right? And then of course, there's a list of YouTube you need to watch, but you don't have to worry about too much about this because he will tell you to do this assignment, you watch this, right? So he would do everything for you. And there's a take-home quiz, project proposal, project progress, final project. We have 3 project time for you and maybe 4 project time for you. So that should be enough time for your project. And assignments, A1 to A7, each of them 1 week, and we have projects, right? So yes, the assignments is very tight and a lot. We try to make it easier, reduce the instruction, reduce the things you need to submit. We also provide some code for you. So everything should be easier. But we think that if you don't have the necessary skills, it's not okay. Yeah. So this is all the skills we think we need. Yeah. Great. So those are the course outline. I put it here tentative. There's a possibility that you guys don't understand something. I put in some extra, I teach that slide again, and then something will collapse, something like that. So there's a possibility in that. Okay. Great. Anyone has any questions? Okay, great. I think this is the last slide for the logistic, and then we can jump to the lecture. But later on, we're going to have a break first. Yep. So grading, attendance, 0%, right? So it's like last semester, I'm going to print a sheet of paper, and you guys sign. Today, I did not print because you guys are not registered, everyone. Some of your names are not there. Some people is still chopping, right? So I did not print that one. For those who sit in, can you join us? Yes, I'm very happy to join me, especially people in my lab. You should study my class, right? But you don't have to sign in the sheet, okay? You should not put your name there. For those who join my class, I cannot miss more than 30% of 22 classes, which is 6. 6 classes. Code assignments, we have 7 assignments. Some assignments will be higher than another, but total will be 55. So you can see that how serious I am, right? So you should treat the assignments very seriously. I don't mind, you can group together, but I already say very clearly, no late work will be accepted and no copying is allowed. So you can ask your friend, hey, can you tell me a little bit which library you use? How do you do? You can, but you cannot just copy the code, paste, and run. No, cannot do that. Okay. If you do that, it's bad for you, right? You cannot do your work. You cannot do your job. You cannot go out and do your career. Then it's not okay, right? Now you may say that you have 4 courses. You have NLP, you have ISDM, HCI, whatever, BIA, right? You have BIA, whatever, right? You have a lot of courses. I recommend you to manage your time wisely, right? Manage your time. Say that, okay, this day is for BIA, this day is for that, Saturday and Sunday is for NLP, right? You should manage your time wisely and don't make everything mess up here. But this is very clear. I hope you guys understand. Any suspicion is deemed 0 right away. Suspicion means that I don't need to ask you. If I feel like there's no way these 2 guys can be same in this line of code. We know, we code a lot, we code a lot, and we are still coding. We know that no one do this the same way. If we see that, we just give you 0 right away. And we just put in the comment, you probably work with this guy and copy something here. Okay? Again, this is not for me. I don't care about grading. I don't care. I already said to you, I don't care about grading, but this is to force you to not do that, okay? Yeah. We have take-home quiz, 15%, right? And we still don't know how to do that yet because this is the first time. Actually, last year we also do that, but it's not so effective, I think, but we're gonna do it better this time. Final project, 30%. Default project is financial advisor and sales chatbot. You can do other projects. So what is financial advisor? So basically, we want you to create a chatbot. You can input all the stocks you like. For example, I like Tesla, Google, Apple, right? You tell the chatbot, please know that my favorite stock is Tesla, Apple, and Google, okay? And then every morning, 8 o'clock, please summarize all the news related to these 3 stocks, okay? And then every morning you wake up, the chatbot will just print some and summarize for you, not just put the links, right? And there's many other functionality you can imagine, right? What is the best way to buy? What is the PE, et cetera, right? So you need to come up with the requirements, right? But I just need to tell you your idea, right? Another way is a sales chatbot, right? So imagine you are Lazada or Shopee guy, and you sell something like Russia, you sell some clothes, right, in online, right? And you have like 1 million customers, and you cannot talk to them all, right? So some people will say, do you have this thing in your inventory, right? The chatbot should say yes, and you can buy it now. Do you want to purchase now? And the customer say yes, it should, okay, purchasing, and then purchase, boom. The database should reduce by 1 inventory, right? So you may think it's difficult. We will teach you all the skills to do it. It's only a few lines of code, right? But out of that, you have to generate more requirements, right? That you think can be your good project of 4 to 5 people, right? For those who sit in, I recommend you that if you don't mind, just join your team, your friend, and tell that I sit in, but I want to also involve the project, right? And help, right? So that is also very possible on your side. Yep. What if you don't like this default project? Maybe you want to do a very theoretical, like Thai language models, right? Or I'm not sure, something that you want to do by yourself, right? You can just tell me, and I check and see whether it's okay or not, right? Can you do like one people? You can, but I don't reduce the expectation, right? You should have the same level of materials. I am aware that you guys are all introverts mostly, and me too. Some of you are not introverts, and introverts have problem working in groups, right? Including me. And I know that some of you have difficulty like, you do that, you do that, and then it's not working very well, right? But try to learn this skill. I'm an introvert and I eventually learned the skill and it helps me a lot, right? So you need to find the way. I cannot teach you because I'm not a teacher in this area, right? But you need to learn to team up with your friend, learn to talk nicely. Not, hey, you do this, huh? Why you don't do this? Why you let me do alone? You should never say like this, right? You need to learn the way to manage your friends, okay? So yeah, but if you have problem, please tell me early so I can, you cannot be in this group, you'll be in this group, okay? Okay, tell me early. But in the beginning, I will let you make your own group, right? So proposal, create a GitHub repository, create a README, put all of this thing in the README, implement, put all the things in the README, experiments, put everything in the README. So everything is like very practical, right? You don't need to write any reports. Everything is in the README, right? And then you guys can say that this is the GitHub when you apply the job. When you write your CV, you want to apply in Google or Tesla, say this is my GitHub, okay? So that is the idea. Writing papers, writing report is useless for your job. Yep. Okay, so I'm not gonna talk about this again because the project starts around midterm. I will come back again and talk about this. Okay, I finished all the logistics. Anyone has any question? If not, we'll take a break first, and then we come back to first lecture. All right, anyone has any question? Okay, let's take a break and we come back. All right, so welcome back to the first lecture on board vectors. Some announcements, some students asked me, will I teach RTML on InterSam? Actually, I'm thinking, but maybe 5 to 6 people already asked me. I will try to think about it, but I may teach, yeah, depending on my TA, whether he is okay to teach it, yeah, because there's a lot of code to be planned. But yeah, probably yes. Yeah. So now let us first start with our first lecture, word to wake. And the first thing we're gonna talk is word vectors, right? So word is word, vectors is a list of numbers, right? So what does it mean? It means that using a list of numbers, we represent the word, right? And vectors can be, another name for vectors can be embedding. Can be embeddings. Right? Or can be representations. They are all the same meaning. So basically, we represent our word. We represent our word like check, like smile, equal to a list of numbers. And usually the dimension is like 50, 100, 200, 300. Probably those will be the amount of numbers we need, right? So you may wonder like how to get these numbers, right? Probably that is the question you have. And the dimension 50, 100, 300, which one is better? Definitely 300 is better, right? So that is something we want to learn, like how do we create this vector, and for those who don't have a very good feeling, like how these numbers look like. what this each number means, right? Basically in the space, right? Each of the word can be something like, there's so many dimensions you can represent a word, right? Is this a positive word? Is this is this a face thing? Is this a head thing? Is this a animal thing? So you can create a 300 dimensions of perspective, right? Right. And then you use this 300 perspective to describe about this word smile, right? So maybe is it positive? Yeah, it's a little bit positive. Face is definitely in the face, like 9.9, and it's in the head, yeah, 10.1. It's about animal, no, minus 2.9, etc. Right? So by using a combination of a lot of perspectives, you can actually create a list of numbers that explain smile. But who come up with this perspective? No one come up with this perspective, and you also don't know what are this perspective. We just tell the computers, please generate 300 numbers that represent a word, all right? Or 50 numbers or 100 numbers, right? So those are the things you need to know about this big topic, right? Today we're gonna learn something called word to vec. You will not use it in the industry, right? This is from 2013, right? But you guys like to always, the famous question is, if it's not used, then why you need to teach me, right? And you guys should already know, right? If you don't know the history, you keep on, you don't know the reasons, then you cannot make new things, you cannot solve problems because you don't know the history, right? So those are the reasoning that you need to learn, right? So that's why we need to learn all this history. But I enjoy this history a lot. Yep. And yes, yep. So now let us move to the next slide. Right. So before I actually start with my class, I want you to make sure that if you are confused with my class, like you cannot understand all the things I throw to you. Actually, I did not throw. I actually already packaged it very nicely, but I throw a lot of boxes to you, right? So you can always advise this slide. This slide can be made only possible because I and the TA spend a lot of time reading a lot of papers and try to consolidate everything into one slide, right? So if you're lost, this should already guide you, right? So in NLP, we have literally 4 steps, right? You tokenize your work. So for example, Chucky is smiling, right? And so when you do tokenization, it will be Chucky, comma, is, comma, smile, comma, ing, right? Comma, dot, right? So those will be what the tokenization do, right? So this is a very, very basic step that NLP everyone do, right? And there are basically 3 ways: BPE used by GPT, right? Word paste used by Bird, for example. I don't remember who used Unigram, etc., right? And then we also have numericalization, in which we convert. Firstly, we need to convert all this to some numbers, right? So this is unknown. So unknown is basically some number. Is could be 89, smile could be 42, ing is like 13, and dot is like 2, right? So these are just unique numbers to remember that this word is this number, right? There's no technique in numericalization. Numericalization just say, these are all the vocabs I have in my store. Like I have all the 1 million words. This is always 89, something like that. It's just an ID for that word, right? So numericalization has no technique. But once you tokenize, you need to apply embeddings. You need to convert this 89 and you need to convert this, let's say 42, to some unique numbers, like a vector of like 2, 0.9, minus 3, minus 4.5, right? And again, could be 300, a size of 300. Right? And this process is called embeddings. Embeddings, right? And there's so many ways. Virtual 2013, Love 2013, 14, Fastech 2015, Elmo 2016, Bird 2018, Sentence Bird 2019, I guess, and SimCSC 2020, right? And I haven't even included those like 2021, 2022. Probably there are more, but I think it's enough already, right? That you can get an idea, right? So you can see that the newer one usually is better, but do people still use Virtual? Not so much. But Glow, a lot of people are still using Glow, right? Right. So so Glow very nice to have, right? Next thing is once you have these vectors, you want to do something. You want to classify whether it's a positive sentence. You want to send this and generate the next sentence, right? You may say, this story is about Chucky adventuring into the forest full of zombies. Dot. And then you ask the computers to generate all the story, right? It can, right? So those are another task that you want to do called generation task, right? So how to do that? So you come to the model, right? The model, right? In which we have supervised learning, in which we have X and Y. X is a sentence, and Y is a label, right? So for example, in sentiment analysis, in which you want to know whether sentence is positive or negative, X is the sentence, and Y is whether is positive or negative, right? And then let's say if we have a task called machine translation, X is basically like source sentence, and Y is the target sentence, right? So those, hopefully you can understand what is supervised learning, right? If you can frame always that given this input, this is the output, this is always supervised learning, right? Summarization, can we do summarization in supervised learning? Yeah, X is a lot of documents and Y is the summary, right? As long as you have the Y, you can train supervised learning, right? Now, in a task in which you may want to do, let's say summary, and X is source, all the documents, and Y is a summary, right? And I want to summarize what? I want to summarize all the Harry Potter. I want to learn to summarize Harry Potter books, right? But I don't have this Y because no one summarized for me. So then what do I do? Then scientists come up with something called self-supervised learning. That is, you don't train, you just train using X. So how do we do that? Well, it's very simple, right? I don't have any more space here. But for example, I have something like Chucky, Harry Potter, Harry is flying on his bloom, bloom, how to spell bloom? Yeah, maybe bloom like that. Yeah, and if we have this sentence in our repository or corpus, right? How do we teach the model to learn, right? If we don't have Y, right? We can let the model to learn the nature of this by doing like this. We can delete this word. We can delete this word and call this a mass, right? And then we can let the model predict this word. And by doing this 1 million times or 2 million times, the model gets smarter, right? It knows that, oh, Harry is flying always on his bloom, right? Harry never fly on the bloom. I can also mask this, right? Right? And I can reopen this one. Then the computer will know that, oh, Harry will always fly with the bloom, right? Harry will not kick the bloom or whatever, right? And if you can also mask Harry, right? And open this too. And you will let the model learn who would like to fly on the balloon, Harry, right? So you can see that masking has a huge power to teach the model a lot of context about what you want to learn. And that is called mass LM, right? We also have something called language model, right? So what is the next way we can do? The next way we can do is, I'm already out of space, and I always have this problem. For maybe something like this, right? I have Chucky. Okay, Harry Potter, right? Harry is flying on his balloon, right? Right. So what I can do? Well, I can do something like this, right? I can say something called language model. Language model. Right, by the way, LM's name. This one also language model. But what is language model? Well, the name doesn't really imply what it does mean, but the idea is very simple. You send this to the model. Whenever you send Harry, it should predict is. Whenever you send Harry is, it should predict flying. Whenever you send Harry is flying, it should predict on. Whenever you send Harry is flying on, it should predict his. Basically, next word prediction, right? By doing this a lot, you allow the computers to know how to generate the next word, right? And that is how ChatGPT do, right? When you talk to ChatGPT, how you talk? Can you tell me how to do this assignment? Question mark. How can it know what to say next? The way to train is this language model, simply, right? So you're using language model, you can do instruction and then followed by the answers, right? By doing so many times like this, it knows what to generate next, right? Based on your question. So those are two very famous techniques you must know. Of course, and based on these two techniques, a lot of things are happening in 2020 to 2023 now. We have fine tuning, make the model even better based on our own data set. We have prompt engineering. I'm not going to talk about that. I saw so many YouTubes. Probably you guys heard of that. Augmented retrieval. Basically, can I use the model I trained on general idea and combine with AIT corpus or any knowledge database and make a chatbot? Can we do that? Answer is yes. Reinforcement learning, right? So those are all the taxonomy you need to know. But if you need to know really is probably this part. This is the fundamental, the first 6 weeks. This is a big topic, low compute. This is a big topic, low compute, right? Because for people who work in my lab, you will realize that making a model requires a lot of money, like a lot. You guys cannot do it, trust me. You guys need a sponsor, right? Like me. And I need a sponsor from someone else, right? So we need a lot of money, right? So the question is how we can make this equally good model or even better with much less money, right? This is a very good question, right? And everyone is trying to do that, right? So there's a lot of talk idea called pruning. We can prune the models parameters. We can learn from a bigger models. We can quantize from 16-bit to 4 bits. There's a path, right? I'm not going to talk about all this because you don't have to worry now. These are all the things we're going to teach you, right? And finally, once you do the model crazily, then we have a lot of metrics that you can measure your models, right? Perplexity for machine translation mainly. We have Blue and Rouge for generation tasks, right? And summarization tasks, for example. This is a more contextual base, and we can also ask ChatGPT to rate our answer to, right? So that is something that we're also going to talk about. Great. I think I spent too much time, but I will quickly talk the rest. This box is not relevant to most of you. This box is only relevant for people who want to do papers, all right? And on your project, I will let you read ACL papers, each of you 2 for your project, right? I don't plan you to be a best researcher in the world, but ACL is the biggest conference in NLP. All the smart guy, the best thing is in ACL, right? So you guys read from this place. Of course, there's so many places, but start with ACL. I'm not going to talk about tasks too much. Maybe when we go to each of them class, we're going to talk about tasks. Tools. These are all the tools you will learn in this class. SpaCy for basic stuff. PyTorch, you guys already know. Huggingface, how do we load pre-trained models? LangChain, how do we create chatbot deployment using fast API? All your assignments, even I did not teach you Flask, Django, React, whatever, right? You guys need to deploy your app in localhost, okay, in localhost. So you don't have to worry like, Chucky, I don't have money to buy a web hosting. You don't need to know. You just launch your Flask or Django or React or even like Streamlit, like very basic thing, and just put it localhost, okay? So the, actually should be plus something like Flask or whatever you want to use, right? Django, whatever. All right. So this is the big picture. I know that there's a lot of stuff here. I will always talk about this slide every time I start my class, right? To make sure that this go to your brain. All right. Great. So I think that's it for the big picture. Okay. So what representations? Again, representations can be represented by vectors or numbers. It can be embeddings or vectors, the same name. So, so the question is, how do we represent the meaning of a word? So there's a lot of ideas. First idea is synonyms before 2000. And basically, you use something called WordNet. You can search in the internet. There's still something called WordNet. You can use it. It contains all the synonym for one word, for each of the words. And then in 2000, we have something called one hot vector. All right. And people realize that, okay, it's better than nothing. And we use it for 13 years. See, we use it for 13 years. You guys are already born, right? Mostly, right? So you guys are in the age of one hot vector. And then in 2013, from now until now, everyone is using vectors like embeddings, like numbers, right? So let's cover this quickly, and then we're going to go to word to red. I'm not going to hurry it today to make sure you guys don't drop my course before. Synonyms. So you can see that if you use something called WordNet, if you open good, there's so many synonyms, right? Good, goodness. Good can be also commodity, right? Blah, 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 right? And you can also take something called hypernyms, right? Hypernym is basically is a relationships, right? So there's a lot of a relationship of panda to all this thing that I don't even know, right? So you can see that maybe the idea is that we can use synonyms, right? But synonym has a lot of problems, right? It's not the right way to represent the meanings of a word because there's no context, right? So here I just create a funny examples. Step on shit is basically real thing, right? Shit is gonna happen. It means bad things gonna happen. This is real shit. Probably not the same shit as this, I think, right? So you can see that based on the context, it can be different, right? So synonym is not good. Synonym is, it's all about context, right? It's all about context, yeah. So, and also if you use synonyms, you are missing a lot of new words. Like these are all your modern words. Wicked from Harry Potter, badass, wizard, ninja. No, you don't see it in WordNet, right? So if you keep on using WordNet, you have to update forever, right? And we new generation, we have so many new Facebook meme, Instagram word that we don't see in the last 5 years. Yeah. And we don't think wordnet or synonym is the right way, right? And again, we cannot compute accurate word similarities, right? So how do we make sure, how do we able to create some vectors that can do something? And we know that good and great are similar, right? We want something like that. So now let's go to the next generation, right? So now people propose one-hot vectors, right? So maybe words can be represented like this: motel 00100. Okay, it's fine, right? So maybe we can represent something like this, like a very unique ID for motel and a very unique ID for hotel, right? But again, it's not so useful, right? So there's nothing we can do. There's nothing we can do with this aside from looking at these numbers, right? Can we dot product? If we dot product, just to review what is dot product, right? So let's say I want to dot product. I want to do motel dot product with hotel. What is the answer? Anyone remember? So if we want to dot product, we put this as a transpose, right? And then we basically multiply this, multiply, and sum all of them, right? That is dot product, right? And you will see that it's 0, right? The answer is 0. It's not true. These two words, are they similar? They are. Well, they are not so they are not exactly the same thing, but they are similar, right? If I have another word called cat, and if I do cat dot with hotel, I will also get 0, right? Right. So it means that this representation does not allow us to do anything else except just ID, right? So once you have this one-hot vectors, this is not useful for us as a developers. We want to have some vectors that we can play around, dot product, learn something, right? So this is not okay for us in an output, right? And so I say these two vectors are orthogonal. For those who are wondering what is orthogonal, basically when you dot product is 0, right? And orthogonal is like this, right? And of course, a vector dimension is a big problem, right? If you have so many words, like if you have 500 words in your repository, then how many zeros you have? Like 500,000 minus 1, right? So those are not feasible, right? So now we need to create a new way to get these vectors. So how do we do that? 2013, we got a very smart guy, probably from Google, if I'm not wrong. And he's just so smart. And I think everyone knows him, right? He's, so basically, firstly, how to encode similarities. And we can base on the idea that similar words usually appear around. That is a philosophy. That is if we want to know the meaning of banking, we need to look around the words banking. So you can see crisis. Oh, banking. Maybe if crisis is very near to banking, maybe crisis should be a vector that is very close to banking. So that is the idea, right? That is the idea, right? Saying is very far from banking, so saying should have a very lower similarities from banking, right? So that is like a philosophy, right? So now how do we do it concretely, right? So here, this is just an example. This is what we want. Let's say expect is a vector, and this how many numbers? 9 numbers, right? And if we squeeze into a 2D, what we want is that we want the closer word together, and we want like there's a you can see that there's a something here, right? that we can see, right? That they are very close together, right? So that is something we want to achieve. And you may say, oh, how can we do that, right? And actually, I would not teach the next thing, but I will show some video about some code that I have written to confirm to you that it's possible. And it will surprise you that by learning some unique vectors, we can do that, right? So I will not go to the materials, maybe next time. Let me quickly jump to the videos I have pre-recorded. And then we can call it a day. So good morning, students. Today we'll be looking at a globe again, but I think this time it's a very short tutorial, and I will be introducing the idea that hey, maybe we don't have to actually code from scratch, right? Coding from scratch is mainly for the purpose of understanding, but once we understand, there's plenty of libraries out there that we can use, right? One of them is Gensim. Gensim is not much used nowadays, but I think there's still a lot of utilities that you can actually explore, right? So here I will be I have downloaded this from the Stanford page, so you guys can search on the Google, right? And you guys can actually download this and put it in your Gensim directory. If you wonder where to put this file, you just run this, and there will be errors, and then it will give you the path, right? So then you can actually just put that file here. So what does this mean? This means that this globe embedding is the embedding size is actually 100, right? And if I'm not wrong, 6 billion represent the number of words. Is that right? Yeah. So the 6 billion is basically the tokens, right? That is learned. So there are a lot of like some of them is like a lot of big numbers, so you can try. But this time we're going to use the small one. All right. This takes a little bit of time. All right, so now we can maybe input any word, right? And try to get the shape. And you can see that each of the word has an embedding size of 100, right? For those who are new to NLP, you may wonder like, why 100? Well, it's just a number that we theorize that this could be enough, but commonly the numbers could be 50, 100, 300, right? 400, right? But I never see any embedding size more than 1,000, seriously. So that could give you a little bit of intuition what would be the optimal size for the English words. And of course, based on this, so we can actually check how whether copy is similar to Obama. Oh, by the way, this is basically a function that check which word in the vocabs actually closest to Obama, and not surprisingly, you can get back George Bush and Bill Clinton, right? And yeah, I just want to let you know that this is the basically percent similarities, right, with all the vocabs in the library, and just list down the top 10 for you, right? I guess if you have looked at my Python tutorial previously, this could make a lot of sense to you now. We can try Coke and cola and Pepsi. Banana is coconut, mango. Language is word spoken. The plant is plants factory. And of course, we can put a negative word, right? And I guess this other word that is opposite of banana, but which I don't really understand this words. But anyway, we can also demonstrate very interesting thing. That is, we can say that, hey, if we take a woman, because these are numbers, right? These are vectors, right? What we can do is basically a plus minus operation too, right? So we can say that, hey, if we take woman plus king and minus man, that should give us a queen, right? Because a woman, but is no longer is a king, but is no longer a man, then that would be a queen, right? So what we can do is similarly passing to this function positive, and then take it a negative man, right? And we can get that queen is the highest probability, right? So I think that, I guess this is a very interesting demonstration of how embedding can be useful to a lot of work, right? Because they are embeddings, they can support a lot of operations, and also I guess it can also be used for the search purpose, right? Here we have Italy and sushi, and maybe we take out Japan, and maybe we can see how does it look, right? And that would be tapas. I'm not sure what is tapas, but I guess for those people who are in Italy, may makes a lot of sense, right? Of course, we can also take a look at cosine similarities, right? So the distance between dog and cat is 0.12. At the same time, the distance between dog and fruit is much bigger, right? This is basically different from cosine similarities, but actually it's just 1 minus cosine similarities equal to distance. I guess this is the same, right? Happy and cheerful is 0.45, and happy and sad is 0.31, right? So this is a surprising result, right? So it does not mean that if things are antonym and it should be very far away. In fact, similarities does not really handle synonym and antonym, right? Because if they are often close by each other, then the embedding should be close to one another, right? So this is a interesting interpretation of word embeddings. But of course, later on, I mean, Word2Vec and Globe invented 2013 and 14 respectively, right? By now, we already have much more powerful embeddings like a bird, which can actually understand the context much better. Here, I want to talk about bias, which is something that we have to be careful. For example, if we try to take what are the type of work that woman works, right? It will give you nurse, right? Which is a little bit biased, right? I mean, nurse does not necessarily should be woman, right? A man can also be a nurse, right? So this bias is not wanted. And where does it come from? Well, basically it comes from the corpus, right? So there's a lot of work in the current state that trying to remove this bias from the corpus. And if you can try to check a man, and so you can see the man is mostly a mechanic and job and workers factory. So I don't think this makes a lot of sense, right? So we as an NLP scientists have to figure this out together. Doctor, and yep, again, woman seems to more toward nurse and physicians. I guess this can be fixed easily by removing the bias from the data sets, right? Because in the early 1900s, maybe a lot of women are mostly nurse. Most nurses are usually women, right? But if we can fix that bias, then it won't appear in the results. This is another utility that we can actually demonstrate analogy, right? Using the same positive and negative mechanisms. So right here, Japan, Japanese, Australian, tapas. And if beer is for Australia, then France is for champagne, right? And I don't understand this much, but I made this out of the blue. But I guess it makes sense. Yep. And tallest, and then the longest, right? And if you're fantastic, then bad is terrible. And bird, fly, and human is bomb. Yep, that's fine. Yep. Of course, another utility of embedding could be something like this, in which we can say which word doesn't really belong to one another, right? And we can say that water, right? Because water is quite far from everyone else. I want you to imagine that all of this is simply operations of minus and plus, right? And but this is a fantastic thing, right? By just doing plus and minus, we can create so many utility that can be useful for word operations. Yeah. And lastly, I have created a lot of words. I don't want to put too many words, so this is the words that I put. And then since the embedding is 100, I applied a method called PCA that can dimensionality reduce the dimension into just 2. So I choose 2 here, and then I just plot them accordingly, right? And you can see that most of the countries club together, right? I guess water is right here, and a lot of food, right? Is and this is the drinks, right? And I think this is the animals, and I think this is exam class. Right. So hopefully you guys enjoy the video, but I think mainly what I want to say is that word embedding is so cool, right? By creating vectors that very meaningful, you can do so many interesting operations, right? You may not able to imagine. That's why I make this video, to let you guys understand the utility, right? Imagine that, can I do search? I can also do search. For example, I say, I have so many PDF. I will say, please find me a document about lung cancer, right? It would take my words, translate to vectors, and then compare to all the vectors, right? Cosine similarity with all the documents, and then we'll find the top K documents that is most similar, right? So you can see that the word embeddings, even though the idea is very simple, is very, very damn powerful, right? And we're gonna learn all this together next week, Monday. Starting Monday, how do we actually create this word embeddings, all right? So I think that's, let us finish it earlier, 5 minutes. Thank you very much, and see you guys next Monday. Thank you.